This TV remote is unable to function because the AA batteries inside of it are dead. After removing the batteries out of the TV remote, you can plug them into the Joule Thief device and it will still function. This is the breadboard prototype for the Joule Thief circuit. As you can see here, a 0.75 volt battery is fed into the positive and negative rails of the breadboard. And there's an inductor here made by wrapping two 16-inch 22 AWG wires around a toroid ferrite ring, and the opposite ends of the wire are placed into the red positive rail. And in this case, the blue wire is fed into a 1 kilo ohm fixed resistor, which then goes into the base pin of the transistor. And then the red wire is fed through this white wire into the collector pin and transistor, and out into the common terminal of the slide switch, and also into this white 2.8 volt LED, which is then also fed into the common terminal of the slide switch. And then the left terminal is fed into the negative rail grounding the circuit. When the 0.7 volts flows through the inductor, a magnetic field is created. And once this magnetic field has reached its maximum capacity, meaning the inductor is saturated, the transistor's base pin slams shut, and all of the stored energy is thrown through the 2.8 volt white LED, turning it on. The Joule Thief device functions the same as the breadboard prototype does, but is assembled on a PCB instead of a breadboard. These two little green things are 100 microhenry fixed inductors, and they work the same as the inductor shown in the breadboard prototype. And they help amplify the voltage through a magnetic field, allowing this 2.8 volt white LED to be powered by a 0.75 volt battery, as you can see here. The stripboard version of the Joule Thief device functions the same as the breadboard prototype does, as well as the actual device, but is instead assembled on a stripboard. A stripboard is like a breadboard, having the same width between the holes, but is permanent like a PCB. This is because on the underside, you can see it is soldered. All the components are soldered to the copper tracks, and you need to take extra care when soldering on a stripboard, as none of these rows are able to be connected and have bridges forming between them. The two 100 microhenry fixed inductors amplify the voltage through a magnetic field, as explained in the breadboard prototype, and so this 2.8 volt white LED can be powered by 0.75 volts, as you can see. Thank you.